Hi everyone. Today in this session we are going to discuss about electrical resistance. In last session we discussed about the potential and potential difference. Okay. So resistance means when electron flows through the conductor, it offers some sort of obstruction to the movement of electrons, or we can simply define resistance as it is obstruction offered by the material to the flow of free electrons in a conductor is called resistance. Okay, now let's see which kind of restriction or which kind of obstruction it gives. If we consider a conductor, it has too much of electrons. Free electrons will be there. Conductors, the number of free electrons will be more. So all these, in normal condition, all these electrons will be in random movement. Okay, consider these are the electrons. And all these electrons are moving randomly in different direction. It may be moving. Okay, now this is a normal condition. Now just consider that we are going to connect it to an external battery. Okay, the conductor is going to connect with an external battery. Okay, so in this condition, how the electrons will move, that we will see it. Okay, so this is in random movement till it connects. It was under random movement. Once it is connected, this random movement is going to align in the same direction. Okay, the entire electrons are going to move to the same direction. Electron has which charge? Negative charge, right? So this is positive and this is negative. So the negative electrons always attract towards the positive pole or positive anode of the external supply. Okay, but in between this one, there is a presence of positive ions. In between, there is a presence of positive ions. So normally we think that when it is connected with an external supply, the entire electron move very fastly or it accelerates towards the positive end. Okay, but it is not like that. When it start moving towards this positive side, it suffers some collision. Sometimes the collision will be between the same electrons and sometimes the collision will be with the positive ions. So when something is collide each other, what happens? The electron is moving very faster. When it collide, what happens? It moves back. Right? No? Then again, when it moves back, again the electron will be attracted towards the positive end. Okay. So simply we cannot tell that the entire electrons, when it is connected to the positive power supply, all the electrons are moving very fastly. It suffers some collision. Again it has to come forward. So we used to call it as drift. Okay. There is no speed movement, only the drift of electrons are happening. I'll say one example. Just consider when we in sports, when we run for 100-meter race, there will be particular track will be allotted, right? No? Okay, just consider you are going to run for a 100-meter race, but more than 20 to 25 members at the same time. Only 6 track is there. You are not separated, allotted the track, but all the 25 members together going to run from this all together, all 6 tracks at that time. How it will be? All of them have the aim to reach the finishing point, right? If 25 members are running together only within 6 tracks, there is a chance of more collision. You will hit each other, right? Now all have a tendency to run faster. In between, you will collide with others or you will hit with others. Then what happens? Some people will fall down, right? Some of them will fall down. Those who have more energy, those who did not get much hurt, Again they will get up and they will run. Right? No? So all of them have a same aim in their mind. They have to reach the finishing point and they have to get the first place. Same way, all these electrons are also running or moving very faster to reach the positive end of the external power supply. But in between, they are feeling some collision. That is the obstruction. That is actually the resistance offered by the conductor. Okay, so that is the resistance offered by the conductor. So the obstruction offered by the conductor for the movement of electrons are called electrical resistance, or simply we used to call it as resistance of a circuit. Okay. As in the case of conductors, the number of free electrons are more. So there is more chance for more electrons to reach the positive end. So that means that's why we used to get more current. What is current? It is a more number of electrons are moving means more current is passing through the circuit, right? So for conductors, more electrons are there. So these more electrons are able to overcome this obstruction to reach the final point or the finishing point, that is the positive pole or anode of the external power supply. Depends upon the material made, it may vary. If you want to find out the unit of resistance, before that we should know what is Ohm's law. Okay, it is a law stated by a scientist named Ohm, and on his honor we given it as Ohm's law. Okay, so according to Ohm's law, or Ohm's law states that the current passing through a conductor is directly proportional to the potential difference across its ends at a condition when the temperature is constant. Okay, or we can write it as I is directly proportional to V, or V is directly proportional to I. There is a condition when the temperature is constant. Okay, so according to our Ohm's law states that the current flowing through a circuit is directly proportional to the potential difference applied across its ends when the temperature is constant. So from this equation, I is equal to V, or V is directly proportional to I. Now we are choosing this equation. V is directly proportional to I. How can we change this proportionality sign? By multiplying with a constant, right? Okay, so V is equal to I into R. We are using a constant R, and that is our resistance. Okay, so voltage, potential difference is equal to current into resistance. From this equation, we will find out the unit of R. Okay, so what is R? R is equal to V by I. Potential difference divided by I. What is the unit of potential difference? It is V. V divided by, what is the unit of current? It is ampere. Voltage by ampere, or instead of this one, we are using another unit called ohm, OHM, and this is the symbol we use to represent ohm. Okay, resistance, the unit of resistance is ohm, and it is a scalar quantity. Okay, it is a scalar quantity. Now we'll see how can we define this 1 ohm resistance. When we'll get 1 ohm resistance, if you want to get this side as left side as 1 ohm, the right side also should be 1 volt divided by 1 ampere, right? So resistance is equal to voltage divided by current. So 1 volt divided by 1 ampere. Or we can define that the resistance offered by a conductor is said to be 1 ohm if a current of 1 ampere flows through the circuit when a potential difference of 1 volt applied across its ends. I'll repeat once more. If a conductor is said to be having 1 ohm resistance if a current of 1 ampere flows through the circuit when a potential difference of 1 volt is applied across its end. Okay, so this is the way how we can define 1 ohm resistance. Now we'll see the factors affecting the resistance. Mainly there are 4 factors which affect the resistance. We'll see that. Okay, first one, material of the conductor. First one, it is material. How material will affect? So I already told you that depends upon the different material, the number of free electrons will vary. Okay, if the conductor has more free electrons, the resistance offered by the circuit will be less, because more electrons can attain or reach the finishing point. Like copper is a good conductor of electricity, so there are more number of free electrons are there. If you see the iron, that if you compare with the free electrons, it doesn't have much free electrons comparing with the copper. So depends upon the material, the resistance will vary. That is the first factor. Second one, the length of the conductor. Length of the conductor. Okay. When we discuss about the resistance, I told you that the electron has to suffer lot of collision, right? No, if the length is this much, that it's connected with the positive supply, the electron which is situated here, it has to travel or it has to cover this much length. That means it has to suffer so many collision before reaching the finishing point. If only this much length is there, it has to cover only less length. So that means as the length increases, the resistance also increases. As the length increases, the resistance offered by the circuit increases. Or we can tell that L is directly proportional to resistance. That means directly proportional means if one factor is increasing, automatically the other factor also should increase. That is called directly proportional. So as the length increases, the resistance offered by the conductor also increases. Now third factor, that is area of cross section. What is area of cross section? Area of cross section of the conductor. Okay, so just consider we have a conductor. This is the original one. So the electron which is situated here has to complete this much distance. It has to suffer too much of collision. Now instead of increasing the length, we are going to increase the area of cross section. Area. So here the electron will get more space. So it reduces the chance of collision. Or else we can tell that the area of the conductor is inversely proportional to the resistance. That means as the area increases, the resistance offered by the circuit decreases, or as area decreases, the resistance offered by the circuit will increase. It's inversely. One factor increases, the other factor should decrease. Okay. Now our fourth factor, temperature. Okay, temperature. What happens when the temperature increases? When the temperature increases, the molecules or the ions will be at ions and electrons will be at random movement. Okay, so they will be vibrating or they will be moving very fastly inside this conductor. So automatically what happens? There is a chance for more collision. If more collisions are there, obviously the electron has to suffer drift. They have to feel too much of drift or obstruction to overcome and to reach the particular point. Okay, so that is the reason I told you that at Ohm's law, the current is directly proportional to voltage when the temperature is constant. As the temperature varies, potential difference never change because we are giving externally. If it is given as 2 volt, we are not changing the temperature external power supply. But if the temperature increases, that means if you are heating the conductor, the current passing through the circuit will automatically reduce. The reason is that the circuit offers more collision or more obstruction, and the resistance automatically varies. Okay, so these are the main factors which affect the resistance. First one material, second one length. Length is directly proportional to resistance. Then area of cross section, it is inversely proportional to resistance, and the temperature, it is also directly proportional to the resistance. Thank you.